As we prepare to take notes over Lesson 13.3, let's first make sure that your notes are headed correctly. This is an executive functioning skill, it's organization, and it will help you as we refer to your notes later in the year. So on your sheet of notebook paper, there should be nothing in the white space at the top. The holes should be on the left-hand side of the paper. On this first line in the left-hand corner, you should have the date. Because I'm not creating this video on the actual day you're taking notes, I've just written the word date. But please make sure that you're writing today's actual date. Directly across from that on the right-hand side is your first name, last name, number, and letter. On the line right underneath it is the lesson number that corresponds with the textbook, and today's lesson number is 13.3, which means we are going to chapter 13 and lesson 3. The last step is we're going to skip the line underneath the title. We're going to go to the left-hand margin, and we're going to put a number 1, because that's the problem we're starting with today. This is what lesson 13.3 looks like in our textbook. In the top left-hand corner is the chapter number and the lesson number. Right beside it in bold is the lesson title, Modeling Volume. Now, volume is if you take a 3D figure and you fill it with cubes. Basically, you're counting how many cubes would fill up a shape. Well, if you have snap cubes, unifix cubes, fraction cubes, you could physically stack them inside a rectangular prism. But in the textbook, you don't have that hands-on way of calculating volume. So these cubes here, we don't know how many little cubes would fit inside. And we certainly can't actually open this shape and pour cubes in. So the focus of today's video is how do you model volume when you cannot physically touch it? How can I determine how many cubes would fit in these rectangular prisms? Well, the answer is mathematically by using a formula. Just like there are formulas for area, there are formulas for volume. And we can calculate how many cubes would fit inside by using those two formulas. Today we are going to work numbers 1 through 4 and use the formulas to calculate the volume. Let's begin number 1 mathematically. We have a cube in front of us. I see that the height of the cube is 3 inches tall. The width of the cube, or the length depending on how you look at it, is 3 inches long. And then if I consider this the width, the depth, it is 3 inches deep. Now I'm switching over to notebook paper so that I can mathematically calculate that volume. In order to mathematically calculate it, I'm going to write the 2 possible formulas that I can use for volume. They are as follows. If you will copy this down on your notebook paper as well. Volume is length times width times height. And notice I didn't have to put any multiplication symbols because when you put variables beside each other, that means multiply. The other formula I could use is volume equals base times height. So if I go back and look at my shape again, I notice that in number 1, 3 times 3 times 3, length, width, and height. So if I'm using the first formula, I will substitute the length, which was 3 inches, times the width, which is 3 inches, times the height, which is 3 inches. And then I'm going to follow order of operations to solve. 3 times 3 is 9. So I just rewrote the problem, but I put 9 where I had originally solved. And then 9 times 3 is 27. Now if I leave it there, this is not a scholarly answer. My cube was measured in inches. And because I just measured 3 dimensions, length is 1, width is 2, and height is 3, this is inches to the 3rd power, and we read that as inches cubed. Circle our answer. Now this formula should give us the exact same answer, because the base of a prism is the area. Well, area is calculated length times width. So if I go back to the picture and I think about just the bottom row of this cube, the area of that would have been 3 times 3, the length and the width. So in writing that, I know the base is 9 because I multiplied length times width to find that area. Now area in 3D is volume. In order to do that, just multiply by how tall it is. So the prism had a base or area of 9 inches squared, and then it rose up from the ground 3 inches. So 9 times 3 is 27. The measurement was inches, and I measured 3 dimensions. The base had 2 of them, length and width, and the height had 1 of them. 27 inches cubed. Number 2 is also a rectangular prism, so I can use the same volume formulas in order to solve. The first thing I'm going to take a look at is the base of my rectangular shape. The length of it is 6, and the depth or width of it is 2. So if I were just thinking about the area of the bottom of this, I would do 6 times 2. But because this is volume, which is area that's become 3D, it's also 3 meters high. So 6 meters long, 2 meters wide, and 3 meters high. Now I can use those numbers to help me calculate the volume of number 2. The first thing I'm going to do is go ahead and write those formulas again. Repetition takes information from your working memory to your long-term memory. So one formula I can use is length times width times height. In this instance, the rectangular prism was 6 meters long. It was 2 meters wide, and it was 3 meters tall. And I'm going to use order of operations to solve. 6 times 2 is 12, and I'm going to rewrite the problem with my new portion of the answer. And 12 times 3 is 36. This rectangular prism was measured in meters, and 3 dimensions were measured: length, width, and height. What this means is if I were to have cubes that represented 1 cubic meter, there would be 36 of them that filled this shape. 36 meters cubed. The second formula is if I find the area first and then multiply it times how tall it is. So the base of the prism represents the bottom layer. That would have been the length and width multiplied together. The length and width were 6 and 2, so the base of that was 12. And then it rose 3 meters into the air. 12 times 3 is 36, measured in meters, 3 dimensions. Even though it looks like only 2, this base is composed of 2 dimensions itself, length and width, as shown here. So it's 36 meters cubed. In number 3, the rectangular prism has a much smaller length and width and a very tall height. That does not change the formula for volume. I'm still trying to figure out, if I open this shape and poured unit cubes inside it, how many cubes would fit in it. So I'm paying attention to the length, which is 2 across. The width is 1 deep, and the height is 7 centimeters tall. By now on your paper, I hope you have already written the 2 formulas for volume. The first one shows each individual step. The length times the width times the height. In this instant, it was 2 centimeters long times 1 centimeter wide times 7 centimeters tall. I'm going to work from left to right with my multiplication. 2 times 1 is 2. When I finish solving, 2 times 7 is 14. What do I need to include in my answer? I need to include the measurements, which were centimeters, and the fact that I measured 3 dimensions, cubed. Now, if you are anticipating me, you have already written the second formula. Volume equals base times height. The base is the area of that rectangular prism, the bottom layer, and that was 2 times 1. So the area was just 2 centimeters. But now we're multiplying by how tall it is to find the number of cubes that would fit inside. 2 times 7 is 14 centimeters cubed. Our last problem together is number 4. This rectangular prism also looks like it's more vertically oriented than horizontally, and that will not change our formula. What are the 3 things that we need to examine in this photo? Look at the length, look at the width, and look at the height. And now we're switching back to our notebook paper in order to calculate that mathematically. What 2 formulas do we need that will both calculate how many cubes would fit inside this prism? Let's go ahead and write both of them. Length times width times height. And if we think of area first and then times the height, base times height. What were the length, width, and height in number 4? The prism was 3 feet wide, 3 feet long, 2 feet wide, and 5 feet tall. Using order of operations, I work from left to right. And what needs to be written in addition to merely the number? This could be jelly beans for all I know right now. 30 feet cubed, which means that 30 cubes that were measured in 1 by 1 by 1 feet would fit inside that prism. Volume can also be calculated by using the base, which is the area of the bottom of the prism. That was already 3 times 2. So the area was 6, but then it rose 5 feet into the air. So once again, 30 feet cubed.